All right, hopefully this video will help you out with recognizing functions. So there's two exercises you have to do for recognizing functions. There's one that's just called recognizing functions, and then there's recognizing functions too. And so there's some things that we have to consider when we're talking about that, so let's try to get into it. I'm going to go ahead and fill out the rest of this here. It's before school right now. Of course, you just put your class period, and it's 9:23. 14. It might be different for you, of course. Our essential question is, what does it mean for, quote, y to be a function of x? So you probably have some experience with the idea of a function. We'll start off at the most basic level. So what is a function? A function is a relationship between two variables. I'm going to put parenthetically or more, where a unique input maps to a single output. So that's kind of a mathy way of putting it. So function is a relationship between two variables or more where a unique input maps to a single output. So let's look at some examples, and then we'll come up with maybe a little friendlier definition. So example one, you might have done some stuff like this where you have 3, 4, and 5. We'll call these our inputs. It's also sometimes called the domain, the set of all inputs. And then we'll have a set of outputs, which is sometimes called the range, the set of all outputs. And so let's say I have this. So 3 maps to 2. Let's say 4 maps to 2 as well, and 5 maps to 3. We're going to say this is a function because, sorry about my handwriting. Let me try to write that a little bit better. I'm going to adjust my iPad here. This is a function because each input has a single output. Now, what you can notice about that is that you have two inputs, 3 and 4, that are both mapping to the output too. That's okay. It's okay for outputs to get repeated, but it's not okay for inputs to repeat and have different outputs. So that's an example of a function. Let's give you an example of something that's not a function. We'll do it in a slightly different context. Let's make a table of x and y. X is usually our input value. Let's say we're just collecting some data. So for this situation, we have x and y. This situation is not a function because the input 2 has two different outputs, which I can write as 3 and 4. And I can highlight those here. That's this input and this input. Since the input x is repeated, that's going to make it so that the output is different. And so you have something that's not a function. And so one way to think about functions is that if you know what you put in to a function, you know what you'll get. And so when we look back at this example up here, if I put 3 into this function, I know I'm going to get a 2 out. If I put a 5 into this function, I know I'm going to get a 3 out. And then there's no confusion about that at all. This one that is not a function, however, if I put 2 into the function, I could get a 3 out and I could get a 4 out. Let's look at one more example. It's going to be kind of like a contextual example. So when I think about the following situation, let's say we have day of sale. Let's say we're having a sale at a retail store, and then we have number of customers. And so you advertise the sale. You have a couple different days of the sale. We have day 1, day 2, day 3, day 4. Well, let me put it this way. So let's say Monday, Tuesday, and then you have a Monday of next week and Tuesday again. Okay, so you have like the week 1 of sale and the second week of the sale. On the first Monday, let's say you have 126 customers show up. On this first Tuesday, you have 112 customers show up. The second Monday, you have fewer people show up. And then the last Tuesday, which is the last day of the sale, you have the most people show up. And so in this situation, you have inputs of days and you have outputs of customers. And so the question is whether or not this would be a function. And the answer is no, because we have inputs Monday. If we put Monday into this relationship, we don't know how many customers will show up. So you can't predict precisely how many customers will show up based on the date of the sale. So we'll say it's not a function because the day of the week maps to different numbers of customers. So hopefully that kind of reviews what a function is for you. We'll look at some stuff graphically here in just a minute, but the basic idea is that you have to be able to look at an input and say exactly what the output is. So let's make our next question this. What does a function look like? I'm going to say it descriptively first. A graphed function clearly has just one output per input. So let's look at a couple of examples. So if, as is usually the case, X is my input, let's say this is my input column, and this is my output axis. Sorry, I'll make my pen a little bit skinnier here. And I have this relationship, which is a polynomial relationship. This one is a function because if I choose any input, which is going to be an input along let me make my tool a little bit nicer here. So if I choose any of these inputs, I choose the input and then I find out where it maps. So I go here, let's say I choose this input right here. It maps to this exact output right here on the graph. If I choose this input over here, it maps to just this output on the graph. And so the way that we shorthand that often is to say that we have a graph that passes the vertical line test. And so what that shows us is that anywhere that you pass a vertical line along this graph, a single output is assigned to each input. So let's look at another one. We'll make a little note. I think you guys remember vertical line test. So our second example here, we'll make it this relationship, which let me improve just slightly. I'll make it a different color so we can see it a little better. Okay, so this relationship, you can tell right away, does not pass the vertical line test. And so let's consider what that means. I'm going to get my little pointer here again. If I choose this input right here, because this is my input axis, if I choose this input right here, it maps to this output, it maps to this output, and it also maps to this output. So this input right here on the x-axis, it has 3 different outputs, which means that this is not a function. Because some inputs have more than one output. We can kind of illustrate that here. It has that output, it has that output, and it has that output. All right, so the big idea here, and this is when you get to recognizing functions too, that you're going to have to deal with is how can I tell if, I'll say, y is a function of x. Okay, so first we're going to make like a linguistic note. Let's consider your cell phone or your iPad. And so like if we look at your iPad, one of the things that you can make on iPads are iMovies. So one of the functions, a function of the iPad is movies. And that's how it usually comes out. Like when we use normal English we say a function of the iPad is movies. Sorry, my E here looks weird. In mathematics, we're going to say that slightly different. And so I'll put a little star here. In math, we phrase it differently. So in math, we phrase it slightly differently. And so what we're going to say is outputs are functions of inputs. So outputs are functions of inputs. So in the case of our iPad, movies are functions of iPads. And so the input is sort of like the iPad, like the stuff that you do on the iPad, and the output is the movie. When you're talking about, let's look at an example that we looked at before. So we had this mapping relationship where we had, I think it was 2, 3, and 4, and then we had, let's just say we have 2 and 5 over here. And so these are my inputs, and these are my outputs. 2 maps to 2, let's say 2, whoops, let's not make that. 3 maps to 2, and 4 maps to 5. And so if this is my y variable, and this is my x variable, y is a function of x because each x maps to just one y. All right, and so you can say y is a function of x just when y is the output and x is the input. All right, so let's say I have this table, however, or even let's do it as a list of points. Let's have the point 0, 300, 1, 250, 6, 175, and 9, 212. And let's call these the variables x and y. Okay, so this is another example. When I'm considering these variables or this set of points, y is a function of x because each x has just one y assigned to it. So you can look at that here. Each of the x's, 0 maps to 300, 1 maps to 250, 6 maps to 175, 9 maps to 212. So there's no spot in this set of points where if I know the x, I can't figure out the y. It doesn't map to more than one spot. However, we can also say this. X is, in this case, a function of y because, and I'm going to look at this, each y is assigned just one x. And so if I look at this, 300 maps to 0, 250 maps to 1, 175 is paired with 6, and 212 is mapped with 9. And so if I know the y, I can predict precisely the x without any confusion at all. If I put y into the function, then I get a specific x out. And so it goes back to this definition that we used before, that if you know what you put in a function, you know what you're going to get out, right? And so this is maybe the most important phrase on the whole page. If you know what you put into a function, you know what you'll get out. And so that can go either way. Like, it doesn't matter which variable you're talking about. You can talk about y as being a function of x or x as being a function of y. So long as you can be sure what you're going to get out when you give it one of the variables, then you can say that it's a function. That's sort of how the language is going to work. There's going to be some problems that ask you to consider this in context. So the discussion I've done with you here is mostly or almost all just pure math, but you're going to have to apply that pure math to situations, and of course your teacher can help you out. We really recommend that you think carefully about how to put all of this together, and so in order to do that thinking, you should take a moment to write a summary that kind of makes sense of all of this. You might try a few problems and then come back to the summary so you have an opportunity to process things. Good luck.